Hello everyone, today I'm going to explain the timers part in 8051. Okay, this is the example is taken for explaining the timer part. In that first one, assume the crystal frequency 11.0592 MHz. Find the frequency of the square wave generated on port P1.0 in the following program. And the second, you need to find the smallest frequency achievable in this program and what is the value of TH value to do that. So as we all know that we need to set the T mode register before going for any of the timer. So we are going to send T mode 20H value. So that is nothing but T mode is an 8-bit register. 1, 2, 3. So 20H is nothing but first one is 0, 0, 1, 0, and again these are all 0, 0, 0, 0. As you all know that the upper 4-bit is belongs to timer 1 and lower 4-bit is belongs to timer 0. In the question itself it is showing that we are going to set for timer 1. Okay, and we need to find the frequency of the square wave generated on pin P1.0. So we are going to set the timer in mode 1 and in timer 1 and mode 2. Then we need to set this if it is in a mode 2 as T mode register is setting to the mode 2, that is nothing but 8-bit auto reload. So only the 8-bit data it is going to accept. Then move th1 comma hash 5. So 5 is the number we selected for making the crystal frequency 11.0592 megahertz. So once you set quit tr1, the timer is going to run. This timer is going to start from 5 and it is going to end up at 255. So how we set this 5 is, first notice the target address short jump. Then in mode 2 we do not need to reload TH since it is a auto reload. Now 256 minus 5. So the question itself telling that we need to go for 5. So already the timer is going to start from 5 is nothing but 256 is the maximum rate. So your timer is starting from 5. So we need to subtract that from the maximum value and we need to multiply 1.085 microsecond. So what is this indicate 1.085 microsecond? You have a crystal frequency that is 11.0592 megahertz divided by 12. So that you are going to get 1.085 microsecond. So 256 minus 5 you are going to get 251. So 251 into 1.085 microsecond you are going to get 257.33 microsecond is the highest position of the pulse. Okay, since it is a 50% duty cycle for square wave, so we need to take half of that. So t is equal to, so 50% only we calculated, other 50% we need to multiply by 2. So 2 into 272.33, you are going to get 544.67 for the complete cycle. Okay, so like this we need to set, and the another instruction which is there here is JNB TF1. So we are setting the flag bit here. Okay, once your counter roll over, that is nothing but once it reaches 256, that is nothing but 255 plus 1. So 255 is the maximum value and plus 1 is the rollover to the 0. So that rollover, once it got the rollover, then this will go to the back until it is rollover. Then after that, we are complementing P1.0 because in the question itself, it is generating a square wave. So first position is higher bit and the second cycle it is a lower value. Means the first is positive value and the other one is negative value. So negative value is the complemented value here. Then clear TF1. So once it is rollover, we need to clear that. So once it is clear, it is not going to work. So short jump back. So like that, it is going to happen. And these are the settings we need to make for generating the square wave in a particular frequency level. Okay, thank you.